Hi everyone, today I'm going to go over the Lab 11 worksheet. We're going to work on the first part, understanding cache and exploring direct map caches. So for this particular page, we're going to be calculating the byte offset, index, and tag for different addresses. To begin, let me show you guys some important formulas to help you calculate the tag, index, and offset bit amounts. To begin, if we have an n-bit address, the order of our tag, index, and offset will be shown right here. We know that the tag will be calculated last because it's just the number of bits in the address minus the index minus the offset. Then we have index, which will be log 2 the number of sets, and then the offset is log 2 the number of bytes per block. One important thing is we might not be given the number of sets. So to find the number of sets, I set up some formulas and then also a table for you to look at. So the number of sets is equal to the number of blocks in a cache divided by n, where n is the n-way associativity. So I have this table over here for finding n based on the set associativity. So if it's direct map, n will be 1, which makes sense because in direct map, there's one set per block, or each set can only have one block. And then two-way is 2, four-way is 4, and then fully associative is 8. And in order to find the number of blocks, in case it's not given to you, is to find the number of bytes in the cache, otherwise known as the cache size, and divide that by the number of bytes per block. So this will be really helpful for this first page that we're working on. So let's get started on the first problem. We're given the address 0xF7E3. So let's write that out first. 1111. 7 is 0, 1, 1, 1. E is 1, 1, 1, 0, and then 0, 0, 1, 1 for 3. So that's our address. First, we need to calculate the tag, the index, and then the offset. We know that the index is just log 2 of the number of sets, and then offset is log 2 number of bytes per block. We'll just do block, okay? Well, we actually have a couple pieces of information already given to us. We're given one, the number of bytes per block, which will be helpful for the offset. We have 32 blocks in a cache and then a 16-bit address. So we know that if we want to calculate offset, we need the number of bytes per block. So let's do this over here. Number of bytes per block will be log 2 of 16, which is equal to 4. Now, if we want to calculate the number of sets, we can assume this is just a direct map cache. So if we want to find the number of sets, we can go back up to our formula here, and then we'll see it's the number of blocks divided by n. And we know that n is 1. If we want to find the number of blocks, it's given to us right here, 32 blocks in the cache, because in direct map, number of blocks equals number of sets. Direct. Okay, so this will be log 2 of 32, which is equal to 5. And if we have our tag, which is n-bit minus index minus offset, will equal 16, which is given to us right here, minus our index is 5, and then minus 4. 16 minus 9 is going to be 7. So we have 7 bits for the tag, 5 bits for the index, and 4 bits for the offset. Now, if we go to our address, we can find the tag, index, and offset bits. So if the tag is the first 7 bits, we know that we have 1, 2, 3, 4, 5, 6, 7. This will be reserved for the tag. Then the next 5 bits are for the index, and the final 4 are for the offset, which lines up perfectly with what we calculated here. Now, if we convert this to hex, the tag would look like 0x. We have 0, 1, 1 at the end, and then 1, and then 1, 1, 1, and then we have to pad with 0 in the front. So that would be our tag. Our index, which is only 5 bits, we want to pad it with zeros in the front, so we can convert it. Oh, sorry, this is binary. 0b, 0b. So we'll have 0, 1, 1, 1 on the right, and then 1, and then we need to pad with 3 zeros. We'll pad with 3 zeros, 1, and then 0, and then the offset will be 0b, 00000011, and I believe we need answer in hexadecimal. Okay, so now we're gonna convert this to hexadecimal. So this will be 7, and then that value will be 8. I mean, not 8b. Then we have 0x1, and then we have e, and then we have 0b03, and these will all correspond to the tag, index, and offset. And that's how you will find the tag, index, and offset given an address, and then also given this bit of information over here. And that should be able to help you get started on the rest of the problems on this sheet. All right, good luck, and thanks for watching.